Hello everybody in YouTube land. This is yet another receiver repair video. Actually, this one's going to be a little bit more thorough. Basically, took it apart, did some assessment. This actually is let me flip it up here so you can tell what it is. This is a Technics SU-V4, and there's two different versions of these. There's one that without the peak indicator, and there's one with. This one has several known problems. Well, at least one known problem. Actually, a couple. I'll go through the first one. Problem number one is these STK chips. Okay. As you may well be aware of, the STK chips are no longer manufactured. Panasonic took this line from Sanyo and repurposed it. They still make them, but they don't make any of the old STK stuff. They make all new SVI stuff for their newer product lines. So STK 8050s are no longer available, genuine, and they are heavily counterfeited. So the only choice of repair is either finding ones that are good pulls, or, genuine new, which is rare, and or rework the existing ones. Matter of fact, there was a recent video done by a fellow YouTuber, 12 volt vids, running into the same problem. So, all right, that's problem number one. Problem number two with this unit is one of the two poles in the power switch is dead. So I can't get full power, so this unit is completely dead. And the third thing I noticed right away is I seen a little wet spot right next to this capacitor, and realized that this capacitor is actually leaking and corroded and bad. And I think it is C603. You can see all the green corrosion around it. It's part of the protection circuit, so it's dead. So I'm looking at all the other parts, make sure there isn't other leaky capacitors. And these capacitors here appear to be heat stressed. You can see the label has shrunk down over the top of the capacitor, so they're probably not long for this world. So most likely I'm going to end up changing all the capacitors if I do decide to fix this unit, which I think I will. So my method on these two chips is I'm going to cut them apart and rework the internals, and using much greater spec alpha transistors, so hopefully the unit will survive much longer than it did previously. But I think I know what caused this one to fail, because if you look real carefully right here, you can just see the cracks. And yeah, you can just see, and actually you can actually kind of see an arc mark, but yeah, that's broke completely free. And this one's next in line. So anyways, first I thought, oh well, maybe I'll get lucky and it's just cracked loose. Well, that's pin 1. Pin 1 is cracked loose, and if we pull the data sheet up to the chip, pin 1 is the VCC line. So this transistor was cutting in and out, and I'd be surprised if it didn't damage the transistor. And actually, it did not damage this transistor. It actually damaged this one. This transistor is shorted, and the way I found that out is this pin is not used. So I was able to meter from here to here, and I got 0 ohms. So this transistor is toast. The opposite chip, both transistors read fine. However, the modification that I performed to this circuit, I'm going to do to this one. Even though it's good, it's going to fail sooner or later because of the known problems with this particular unit. So I'm going to rework both of those chips and get them up and going again. But before I do that, let's go ahead and do a quick inspection of the rest of the board and make sure there's no cracks or anything obvious. And yeah, this stupid glue at one time used to be yellow. It ain't yellow no more. I gotta get that glue up too, because it can create shorts, as several other people on YouTube have mentioned time and time again. It is true. It is true that can happen. Let's see, anything else in the amplifier section? Ooh, yeah, I can see a crack right there. Just a little bit. Yep, just see that. So I'll definitely have to take care of that problem. But so the next thing is how to get this friggin' thing out, because as stupid as they are, Matsushita decided to design this thing that the screws come in through the back side instead of the front side. Well, this board is right here, and there's cables that run all the way around to the front panel controls from this board. You can see the ribbon running off. So removing this board is not going to be an easy option. So I think to make life a lot easier is I'm going to remove this bracket assembly and pull this whole heatsink out of here. Unsolder both chips and pull the heatsink out, because I have to re-engineer this thing anyway. And the problem that I have on hand currently is, oh God, this thing's heavy. The problem I have on hand currently is this chip consumes all surface area available in the heatsink. So I have that little block next to it, but on the other side I don't have anything. However, these heat sinks, these little top pieces here and here, are removable. So I need to see, I guess if I rebias the amplifier, it won't be so bad, but when I remove those heat sinks, I want to use the surface area underneath these to put the new output transistors. And maybe even get some aluminum bars and bolt the thing back down. I haven't decided yet. We'll have to play that one by ear. But until then, that's my only solution at this point. So that's it. That's all I got for right now. So let's see. If I pull the heatsink out, do I have enough room to get that out? It looks like I do. I could swing it to one side and pull this thing out. Alright. This will be part 1 of the series. So in the meantime, that switch, one of the 2 poles is still good, but the reason why the switch failed is whoever soldered those capacitors on there, these are supposed to be spike suppression caps. Well, they solder them on the wrong lugs, so those caps essentially did absolutely nothing. So of course the switch failed. One of the poles is still good, the other one's bad. I can unhook that, run it, put a little relay somewhere in here, and just use the switch as a low current to a relay that runs everything else. That's the best solution I can come up with right at this current time. So this will be part 1 of the series. If you have any questions or comments, please feel free to leave one. Thank you.